Nicole's in the chat. Part-time Larry, Sean Graylish, Dave
Larry,
Wilson is
Part-time
here.
Larry sounds like a party.
That guy is a
love that
riot.
name.
Guy is a riot in the chat.
Hey everyone, welcome back. In today's video, I'm going to show you how to build a financial advisor using Python and OpenAI embeddings. Embeddings? Why aren't you just using ChatGPT? Well, a few reasons. Number one, there's no reason for a tutorial on ChatGPT. There's so many different tutorials on it, but if you want to ask it a question, just use it. I don't need to make a video about it. Secondly, there's some limitations of ChatGPT, as you've probably found out by now. If you try to ask it about recent information, such as something that happened in 2023, it'll be like, I don't know what the hell you're talking about. I wasn't trained on that information. That was from, I know about stuff from like 2019 or a couple years back, right? And so we need to come up with some way to be able to feed information from the present into our system so that I could use context from the present to answer our questions. Another limitation of ChatGPT is it often dodges certain types of questions. So if you ask it for advice about your finances, it'll be like, well, I am but a simple AI. I'm not capable. It plays dumb, right? It dodges certain questions because they don't want the liability of giving financial advice. So it'll often say, talk to a financial advisor. And so what we want to do here is come up with a solution to train GPT-3 to just answer a question based on some text that we provide it. And so we can provide some good answers, some good context for it to use, and just say, answer a question based on this text. Another limitation of systems like ChatGPT is that they're trained on only publicly available information. So it crawled the web and got all this data that it crawled on the web and learned from that. But what if we want to train a system on internal information? So there's tons of information, like anywhere you've worked, they've had some private information available, some internal training documents, PDFs, guidebooks, manuals, that kind of thing. And so what if you want to train a system, a question answering system on private information? Well, you can build a custom solution using Python and OpenAI embeddings, and you just need to write a little bit of code to do that. And so just as an example here, I have this copy of this Series 7 exam manual here, and it has a lot of information about stocks, securities, bond characteristics, debt strategies, all kinds of stuff that maybe ChatGPT would answer questions based on this. I'm not sure, but imagine having tons of PDFs internally with all types of different answers to questions, and you don't want someone to have to read through this whole thing, scan for it, and find the information, read this whole thing. They just want to ask a question on how to handle a situation, and we can just use our program to look up and find the appropriate information and generate a nice response automatically. Another example of this is let's say you're this guy, Ben Carlson. You've already written a blog with tons of different posts. And so you have this big corpus of text. And he's also written some books that are not online. So A Wealth of Common Sense. It's on Amazon. You can buy it. But I've seen where some people have written, there's a site, Ask My Book, where you're able to talk to a book and ask the book a question. So maybe he wants this marketing site where he wants to let people ask a question to his book and give the link to buy the book as well. And so there's a lot of different ways you might want to use question answering on private information that's not on the public internet. All right, that all sounds good, but what are we actually going to build? Well, we're going to build this little web interface where we can ask a question to a financial advisor. Now, what is this financial advisor trained on? Well, I took the information from a whole series of podcasts. So Ben Carlson, who I just showed, runs a podcast called Animal Spirits, and he's also part of a collective called The Compound and Friends. Clip at the beginning of the show. I'm a fan of that channel. I go in the live stream and so forth. And so they've talked a lot about different financial topics. So what if I want to train a bot that answers questions the same way they would answer them, right? So what I did was use OpenAI Whisper, which we talked about, and I transcribed all of the podcasts that they've ever produced. I vectorized them using OpenAI embeddings, so I have a numerical representation of all the text they have spoken. And then what I can do here is ask a question here and then use prompt engineering, which we also discussed, to say, answer this question that I type in based on this context that I provide. So what I'm going to do is I'm going to type in a question. I'm going to convert the question I type into a vector, and since I have this corpus of text that's vectorized, I can use the cosine similarity that we discussed to find which context in my big corpus of text is closest to the question I asked here, and then I can just pull in that context, right? And then say GPT-3, use OpenAI API and say, write a response to this question based on this relevant text. So we find the relevant text from the podcast and then we answer the question, generate an answer based on that context that's provided. And also using our prompt engineering, we can say, answer this question in the style of Ben Carlson, since it's trained on words that he has spoken. So just as an example here, let's show how this works, and then I'm going to show you how to build it using Python. So I'm going to say, not to brag, this is something they often say in the show, not to brag, but I have enough cash to buy a house outright, right? And then I'm going to say, should I use all of my cash to buy a house, or should I take out a loan anyway and invest the rest of the cash in the market? Okay. And I'll ask that question. I'm going to say, ask a financial advisor, and then it's going to search this entire podcast, come up with the appropriate text, and craft some type of response to here. So congrats on your financial success. So Ben's a nice guy. He tends to say congrats. I'll often see this answer with kudos as well. He says kudos a lot. So says, first of all, congrats on your financial success. I think it's great you have saved enough. Purchase a house outright. That says important to consider individual preferences. If you're comfortable taking on debt, blah, blah, blah. So it answers the question in a similar way that it was answered on the podcast. All right, so I've explained the why and the what we're building and given a brief demonstration of the project. Now let's go ahead and get to the coding part. So I'm gonna walk you through how to code something like this. And I think this is gonna take me 2 videos. So in this first video, I'm gonna walk you through a Google Colab notebook that explains the logic of how we extract information from a single podcast, generate the embeddings, and ask a question to this podcast, right? And then once we understand how to do one of these, we just need to take this same concept and apply it to a batch of podcasts. And so we're going to build this pipeline where we can just send in a batch, like all the videos for a channel, a YouTube channel, for instance, transcribe all of them, convert all of them, and so forth, get all the data prepared and cleaned up. And then I'll also show you how to build the front end for this. So where you can ask the question in the little text area, deploy it on the web and have an actual site, askfinancialadvisor.com or whatever, and have it query this backend, this big corpus of data that we've already prepared. So let's first focus on this first part. And if you watched video 5 of this series on OpenAI embeddings, you're already way ahead of the game. And that video is now starting to take off. It was the least popular, and now people are starting to get why this is a very powerful concept. Because this concept, there's going to be multi-million dollar, billion-dollar businesses possibly built on this exact concept I'm showing you here. And I encourage people to take all this code. I'm going to link it below. You can just take it and build stuff on top of this, and hopefully you can come up with your own unique idea and create tremendous value. Everyone wants to talk about AI for short-term trading and whatnot, but think you can build tremendous business value here and build something way bigger and generate massive wealth if you're able to find a great use case for this. So definitely be thinking about that. So here we are in the Colab notebook. Follow along with the link below. And the first thing I'm going to do is execute this first cell. And so if you run this, it'll show what kind of GPU you have available. And this will transcribe really fast. You'll still be able to use OpenAI Whisper with a CPU, but it'll just take a lot longer, right? And so I'm running that. You can see I have this Tesla T4, and this is just to show what GPU you have available. The next thing we're going to do here is we're going to install OpenAI because we need the OpenAI Python package. We're going to install it with pip. And then we're also going to install PyTube, which is the Python package for interacting with YouTube videos. And so what we're going to be doing is accessing a single podcast. And so this YouTube video here that I have linked, I'm going to open that real quick so you see what we're dealing with. So you see this is an example of the Portfolio Rescue podcast right here. And so what they do is take questions from the audience and he answers them. And the nice thing about this is they're all time-stamped. And so you'll see there's questions about inflation. This guy owned Twitter stock. And so we have these time-stamped questions here. And so what I did was take advantage of the fact that these timestamps are there. And so what I can do is transcribe this podcast, find the text transcriptions that correspond to these timestamps, and then I can train this question answering bot. So if someone asks a question similar to one of these timestamped questions, I can generate a cool answer based on what Ben said, which also raises whether you should train models based on what a person says. But to pay it forward, I'm recommending their podcast. I'm going to deploy the site and say buy his book and so forth. And I've already bought a bunch of stuff from these guys, so I'm supporting them. I'm not making any money from this tutorial or anything. So I feel like I'm helping actually. So yeah, the ethics thing is a whole another conversation, and that is ongoing as we speak. So regardless, I am taking the text here and training this thing based on it. So yeah, so I'm installing OpenAI and PyTube. So PyTube is able to download a YouTube video based on the URL. And so what we're going to do is use PyTube to download that video. Okay, so once we install PyTube, we're also installing OpenAI Whisper. We've done a tutorial on that already. So that's video 2. I did OpenAI Whisper. And what Whisper does is it can take audio and convert it, transcribe it to a text transcription, right? And so I'm installing the OpenAI Whisper package right there. So it's installing both of those. Now, once those are installed, I just need to import those libraries. So I'm going to import OpenAI, and I'm going to also import Whisper. We're going to be using pandas data frames, so I'm also importing pandas. I'm importing YouTube from PyTube, right? This is the YouTube library for downloading YouTube videos. And I'm also importing this get pass. And so what this is going to do is prompt me for my OpenAI API key. And I need that so I can call the OpenAI API. We covered this in the video number 3 on the earnings call summarization. So we talked about how to use the OpenAI API. So all these concepts that I'm discussing here, I've made videos on them, and now we're putting them all together into larger and larger projects. So I'm dropping my OpenAI API key in here and pressing enter, and now that's stored in the API key here, right? I'm also specifying a couple of models. We discussed the DaVinci model, so that's used to generate responses. So this is the more fancy language model. It's more expensive than the other models because it can generate more sophisticated answers. And then we have the embedding model. So text embedding ADA002. And this is what's used if you watch video 5, which is on OpenAI embeddings. What it can do is take text and convert it to a vector representation. And this is really cheap to call. It's like 0.0004 cents or something like so, fractions of a cent here, right? And so what I'm going to do here is use Whisper. We're going to load the base model, which is good enough to transcribe a podcast. And so I'm going to load this model. You see it downloads the base model, which is 139 megs. I could use a larger model, but I don't think it's necessary for this podcast. This is going to be accurate enough. And so once I've loaded that model, what I want to do is download the YouTube video. So I provide a URL, and then I'm going to instantiate this YouTube class here. And so I will run that. And then once I do that, I can get a list of the streams associated with this YouTube object. So YouTube video.streams.filter. And I've demonstrated this already in more detail, but what you'll see here, if you really want to see what's available, you can dir this real quick and show the various attributes available here. And so you can see I access the streams attribute. And so the streams is a list of various quality streams of different bit rates and so forth. And so there's like a HD YouTube video and so forth. And so what I want to do is just extract, filter down and only pull the stream, the audio stream, right? And then I'm using .first here to get the first one. So there's multiple ones in a list, and I'm saying, give me the first audio stream in there and download it and save it as financialadvisor.mp4. And that'll save it to the file system of Colab here. And so if I refresh there with that button, you'll see I have financialadvisor.mp4 right there. And I could even download this and play it, and you would have the audio of this YouTube video. And so we have the audio now, right? And I can click that, and since I've loaded that YouTube video using PyTube, you can see the description there. And so I showed you this description has these timestamps in it, and it also has a description of the show. And so I have all this metadata here. And so now I have timestamps. I have some questions associated with this, and I also have the audio. And so I can use OpenAI Whisper here, pass it the file name, and I run this, and this will transcribe that audio file and convert it to text. So I'm running the transcription now. I should have a pretty fast GPU here, and this should execute and finish in like a minute. If you don't have that, and if they don't give you a free GPU here, it might take like 6 minutes. It takes a little bit longer sometimes. So just know this will take a little bit to transcribe. So it looks like it finished in a little over a minute there. And now if I print the output, you'll see I have a lot of text and different points in time here. So you see the text like, but yeah, that had to be tough. I've been in the office for 6 years, blah, blah, blah. So you see we have some text, and then I'm gonna access the text attribute. So you can see the structure of this output here. But if I just output the text here, you'll see, welcome back to Portfolio Rescue. So that's the beginning of the show. This is a show where we take questions from you and so forth, right? All right, so the next thing I did here was just create a list of all the URLs and just put it in a Google Sheet here. And so this is all 60 something episodes of the show, and I went ahead and just extracted the descriptions already. This way we can just process this in batch, right? And so for this particular episode, this is, I believe, episode 21. Let me find that episode. This is actually episode 22, actually. So that's the URL for it. And then I have timestamps for all those questions that came from the description. And so what I'm going to do here, I just have a sheet of all these questions already. And so I just exported this as a CSV, and it downloaded to my desktop. And so what I'm going to do now is click this upload button here and upload this CSV. And this CSV just contains a CSV file of those questions and timestamps. And so what I did here is a little bit of data manipulation. And so what I'm doing is taking this spreadsheet here, loading it into a pandas data frame, and I'm going to convert these to seconds. So 2 minutes and 16 seconds would be 136 seconds is where this starts, and then I'm calculating the end time of this particular question. So I'm creating start and end timestamps for each of these questions, and then I'm outputting them in a pandas data frame, and then I'm going to save this to a cleaner questions.csv file here. And so depending on what data you're working with, you can work with this one. Maybe you can jump straight to this step. And so let me open this question CSV and show you what this looks like now. And so basically I transformed that Google Sheet I just showed you into this format. So that way I have a flat episode 1, episode 1, episode 1. I have the YouTube URL link. Now I have a start timestamp. So I put that in its own column. I calculated the start time in seconds. That way, if we build an interface for this, we could actually link to the timestamp in the YouTube video and play the YouTube video starting at 3 minutes, 7 seconds, like from our own interface. And so you can see right here where I'm processing this Google Sheet. I'm looking at the next row, getting the start time of the next row, and then assigning that as the end of the previous row and so forth. And then I'm filtering out any one that doesn't have an end time, just setting it to 0. And so you can see my nice normalized, cleaned up sheet looks like this. And I just have start time and end time for each question. Once that where it's just the end of the episode, I just have it go to the end and I just put a 0 there. Okay. And so, yeah, I just have a list of questions and start and end timestamps, which is great. It's just in a flat file there. And now what I can do is read this CSV file back in. And now I have this clean data frame of questions and start and end time. And so what I'm gonna do here is make a copy of this, and I'm just gonna operate on one episode for this video. So I'm just going to say, find me the rows in this pandas data frame where the episode column equals episode 22. And so I'm just gonna get a small sample here so that we can see exactly what's going on. And so now I just have a simple CSV, simple pandas data frame of just the questions that were asked in episode 22, 1 per line or 1 per row, and start and end timestamps in seconds right there. And now this next chunk of code is where it gets a little bit tricky, but you should be able to understand this. Let me try to go through this line by line. What I want to do is take this transcription. So I have this output segments here, right? So if you look in here, these are the output segments. So these are all the sentences that were said, and I have a start and end time for each of these pieces of text that was provided by OpenAI Whisper. So this, I've been in the office for 6 years. You can see that started at 1,454 seconds and it ended at 1,460 seconds. So we have these little chunks of text that are in our OpenAI Whisper transcription, and we know the start and end time in seconds of each one of these words and sentences, right? And so what I want to do is take my transcript and find all the words that are spoken between this timestamp, start and this timestamp end, and that's the text that answers this particular question, right? And so what I have here is I'm creating a new column just called context, so I want to get the text that answers this particular question. So right now in my data frame, I just have the questions. And so I create a new column called context, and I'm going to set it equal to get the question context. So I'm going to call a function on each one of these rows that's called get question context. So for each one of these rows, I'm going to say get question context. And so what I'm saying here is filter the output segments, so that big list of the transcript, I'm going to say filter it and only get the ones that are part of this particular question. So on question 1, I'm going to say get all the text that's part of the question that starts at 118 seconds and ends at 210. So it's applying a function to each row, and this function is part of the question, takes a start and end timestamp and a segment, and it sees, oh, well, if the segment start time is after the start that I've provided, and if the segment ends before this end timestamp, then it's part of the question, and so I can return true. And so we can take all these segments, put them all together, and so when I run that, you can see how I was successfully able to get this question, find all the parts of the transcript, all of these segments that fall between 118 seconds, 210 seconds, then 210 seconds, 316 seconds, and so forth. So these are just pieces of the transcript where Ben is addressing that particular question. And so now I have a question and an answer that includes the question in it, right? And so now that I have this pandas data frame, I can start calculating my embeddings. So if you watched video 5 of this series, you know that an embedding is simply a numerical representation of a piece of text. And so we have this big piece of text, right? And we want to calculate some series of numbers that represents this text in a vector space, right? And so I import this function called getEmbedding, and I just need to give it some text to get an embedding on. And let's just show what one of these looks like. So I'm going to run it, just getEmbedding on the very first row. So I'm going to get the first location, so the 0th index context here, which will be this one. And I'm just going to calculate an embedding for it, and let's see what that looks like. And you should just see a series of numbers. So this calls the OpenAI API and gets an embedding, and you see it's just some huge list of numbers right there, right? So that's what getEmbedding does. Now what I'm going to do is create a new column on this data frame. So my data frame is called episode. I'm going to say create a new column called embedding, and then calculate an embedding for this row, this row, this row, and this row, and so forth, every row in there. And so what I'm doing is taking each row and applying the function getEmbedding on that row, right, using the engine text embedding ADA002, and I'm going to store the results inside of embedding, right? So taking the context for each row, getting embedding for it, and just assigning it back to the column. And if I do that, I'll have a new embedding column that just has a bunch of numbers in it. And so I'm going to print out what that episode looks like with the embeddings. And so you can see here, now I have all the questions, I have all the contexts that were extracted from the transcript, and I have an embedding for each one of these contexts right here. So I have this numerical representation, it's applied to all rows, and I'm outputting episodes so you see what this data frame looks like. Now, if I run this again, it'll keep calculating the same thing. So this actually cost, let's say, a fraction of a penny here, but I don't need to calculate this over and over again. So what I'm going to do is cache this and save it to a CSV file. So I'm going to save it to a CSV file as well. And so let me run this, and I'm going to output it to a CSV file. And now you'll see I have this nice CSV file called questionembeddings.csv. And if I open this up, you'll see I have a flat file containing questions, context that's extracted from our transcript, and this embedding that we calculated using OpenAI. So now that we have this flat file with context and the calculated embeddings here, we've done the hard part here. So what I can do now is type in a question. So I'm just going to store a question as a string here. Should I buy a house with cash or get a loan and invest the extra cash in the market? I'm going to get an embedding for that question. So convert that question to a long series of numbers. So now that I have a vector representation of my question, I can say, find the vector in here, calculate the distance and find which one of these blocks of text, these vectors, is closest to my question, and use that to generate an answer. And so to do that, I'm importing this cosine similarity function, and that allows us to calculate the distance between these two vectors. And so what I can do is create a new column called similarities. And so what I'm going to do here is say, take my embedding column, go through each row and say, calculate the distance using cosine similarity. So calculate the distance between this vector and the vector of my question, calculate the distance between this one and my question, and so forth, and then sort it by the most similar. And so when I run this, you should see this data frame is now sorted by the answers that are most similar to my question. So you see this one has 0.87, 0.79, 0.76. So they're in descending order right here. So this top one should be related to this question about should I buy a house with cash? And indeed, it looks like it is. So if I expand that out, you'll see this one contains, at interest rates so low, should I instead take a loan, finance a house, and invest my capital in the stock market? So this top result is the most relevant to my question, and maybe even the second result might be related to my question as well. So let me look at another one, paying off a mortgage. It's another question or another answer that's related to my question, and so forth. So you can see how we're able to find the relevant text that applies to our question that was contained within the podcast. The other thing you'll see here is I call .head5, and so that is just getting the top 5 most relevant results. So I'm ordering by similarity for the whole data frame, but then I'm saying just return me the top 5 there, all right? And so I have that stored in this data frame called episode, okay? And so what I can do now is I'm just going to say those top 5, use that as my entire context for answering the question. So this is my knowledge base that applies to my question. And so I'm going to use this to call GPT-3. And so I'm going to build a list called context here. And so I'm taking all of these contexts, so there's going to be 5 of them. I'm going to join them all together into one big blob of text with lots of information about house buying and low mortgage rates, right? So the most similar text to my question that was extracted from this podcast, put it in one big blob of text here, right? And so that's my larger context. So now that I have this big blob of text that applies to my question, all I need to do now to finish this up is call GPT-3. And so I can use the OpenAI API that we discussed in video number 3 of the series. I can call openai.completion.create, and I need to give it a prompt. What prompt am I going to give it? I'm going to say, answer the following question using only the context below. Answer in the style of Ben Carlson, a financial advisor and podcaster. I can also say something like, if you don't know the answer for certain, say, I don't know, right? And so prevent it from making up extra bullshit, right? And then I'm going to say context, and I'm going to provide the context here that I've extracted from above. And then I'm going to put the question that I have in my variable up there. And then that's all part of the prompt. And I'm going to say, put the answer right here. And if I run that, you can see it gives me an answer here. It's hard to take that one back if you buy the house in all cash. I think if you have a low payments tax advantage, you have to think about that in terms. And it provides a lot of things to think about there. So there you go, mission accomplished. We're able to build a question answering bot based on text that's contained within a podcast. So we're able to use OpenAI Whisper, extract all the text from a podcast, all the different timestamps, and construct this nice flat file. We're able to build a data frame with all the start and end times for each question, extract the context for each of those questions, and answer for each of those questions from the transcript. Then we're able to calculate embeddings using the OpenAI Embeddings API. And then we're able to calculate an embedding for our question and find the most relevant text to our question and use OpenAI's API right here to generate a response to a question that was discussed in our corpus of text. And so you can see how you could apply this concept to your own set of documents or your own audio, your own video, your own private internal documents, and maybe you could build some cool value out of this, build a question answering bot for your ticketing system at work or a support chat bot, all kinds of cool stuff you could build with this using this very simple concept of embeddings that has been provided via this nice, easy to use API. So yeah, that's it for now. In the next video, I'll show you how to do a pipeline to batch all these up, transcribe them in batch, and build a user interface for this so that you don't have to run it from a notebook. So it's nice and you could deploy it on the web and have end users use it without having to know anything about embeddings. They just want to type the question and get an answer. So let's wrap this up in the next video. So thanks a lot for watching. See you in the next one.